How do you find an equivalent force? An equivalent force is a single force that creates the same net force and net moment as a group of forces. Say you're analyzing a beam with this group of point loads on it. To find the equivalent force for those loads, start by adding the loads together. Stack all the forces from tip to tail and draw a new force from the start of the first one to the end of the last one. This gives you the net force for the group of loads. The equivalent force will have the same size and direction as this net force. Finding the location of the equivalent load takes a couple more steps. First, find the net moment created by the group of loads. You can pick any point as a reference point for calculating moments. I typically like to use one of the supports as my reference point since that makes things easier a little later on. Whatever point you pick, find the moments created by all the individual forces about that point and be sure to keep track of whether each moment is positive or negative. Once you have those moments, add them together to get the net moment for the entire load group. Now you have everything you need to determine the location of the equivalent force. Since we picked the support as our reference point, only the vertical components of the loads contribute to the net moment. If you divide the net moment by the vertical component of the net force, that will give you the distance along the beam from the support to the equivalent force. Place the net force that far away from the support, and now you've gathered up those point loads into one equivalent load that does the same thing. But why would you want to find an equivalent force in the first place? You don't have to find the equivalent load to find the reactions on this beam. You could calculate the reactions for the individual loads and add them up to get the totals. It's a good approach, and it would tell you the contribution of each load. The main drawback is that to solve for the 3 reaction forces, with 4 loads and 3 reactions for each load, you'd have to solve for up to 12 unknown forces. That could take a while if you're solving by hand. Since the equivalent load creates the same net force and net moment on the beam as the entire group of loads, it creates the same reactions too. Solving for the reactions of the equivalent load cuts the number of unknown forces from 12 down to 3. Fewer equations means faster results and fewer opportunities to make mistakes. If you need to find reactions quickly and don't need any info about a certain load, I'd recommend using the equivalent force method.